A lot of these are actually word problems, so I'm going to have to send them to you.
All right. Actually, they're word problems, but if they're law of sines, law of cosine problems, they're really triangle problems.
Right.
So it's all you have to do is figure out how to draw the triangle, and that turns it from a word problem into a triangle problem.
Right.
Let me know when you've sent it.
Okay, this is the first one. It's sent, so.
Haven't gotten it yet. Is there anything you can verbalize that while we wait for that email?
Yeah. Did it go into the spam folder? It's a notification popped up.
Yeah, you know what? It looks like it might have. Is that your phone number?
Yes.
Okay, 6134. Huh. All right. Let's have a look at it. It doesn't happen very often. Google is pretty good at their spam folders, separating it. Now see, this is just a triangle problem, and it's all about figuring out their paragraph.
Right.
All right, so let's draw it. Hold on a second. All right, so there was a small tree that was leaning. So let's do that. They nailed a 6-foot strap into the ground 4 feet from the base. So what they really mean is that there's the 6-foot strap and it's 4 feet from the base.
Okay.
We attached the strap to the tree 3.5 feet above the ground. Oh man, what the hell does that mean? To keep it, we nailed a 6-foot strap into the ground 4 feet from the base of the tree. We attached this, well, I guess that means it's not a 6-foot strap. In other words, that measurement is going to be 3.5, not 6 foot. That's the way I interpret that.
Okay.
And what they want is, what is theta? How far from vertical was the tree leaning? Well, actually what they want is
90 minus theta.
yeah, alpha. So we can figure out theta, and then we can figure out alpha. What's theta equal to? And the way to solve these is always try to figure out a trig function of theta. Which trig function would you use?
Tangent.
Okay, so I can say tangent of theta equals what?
3.5 over 4.
All right. Now, how do I solve for theta?
You take the inverse sign?
Inverse tangent
Or, sorry, yes, inverse tangent.
of 3.5 over 4. Do you have your calculator?
Yes.
What angle does that come out to be?
41.2.
What kind of calculator do you have, William?
An N-spire.
Okay. So it always tells you whether it's in radians or degrees?
Yeah, and then I have my calculator set in radians, so whenever I take the inverse sine of something, I need to hit the little book button and convert it to degrees.
Okay. And that makes sense because the inverse tan of 1 is 45 degrees.
Right.
So the inverse tan of a number slightly less than 1 being 41 degrees makes all the sense in the world, which makes the answer what? What's alpha?
48.8 degrees.
All right. And I believe that's what they meant. Sometimes it's hard to interpret these paragraphs. In other words, why did they say it was a 6-foot strap? I don't get that.
Yeah, that seems redundant.
Well, it seems like it's thrown in there to intentionally confuse you. It's not just redundant, it's irrelevant. If the strap was attached to the tree 3.5 feet above the ground, then the only distance that matters is 3.5 feet, not the fact that the strap was 6 foot long. All right. Did you send more, or is this it?
I'm sending another one right now.
Okay, close that one. Let's see whether it goes to spam or the inbox. Went to spam.
Huh.
Well, no, it didn't. Went to spam. That's odd that it came into my inbox at the same point that I got something in spam also. All right, is this the next problem?
Yes, it is.
All right. I'm going to call you. Our audio is breaking up.
Yeah, go right ahead.
Okay. All right. Here, let me turn my volume up if it's not up already. All right. This is going to be a triangle problem. In other words, every word problem you get in this part is a triangle that needs to be solved. Okay, where you have 3 pieces of information. Well, let's finish drawing the triangle. And they want to solve for theta. And let's see. So the Earth's radius is 93. And Venus radiuses is 67. You get those two numbers?
Yeah.
and theta is 15 degrees. They want to know what that is. How far is Venus from, hold on a second, I've misinterpreted this. Let me look at it again. S is the sun. They want to know how far Venus is from the Earth. I just got my 67 wrong.
Yeah.
67 goes here, and there's Venus, there's the Earth. They want to know, and this is the sun. So they want to know X. You with me?
Yeah.
There are two possible results. That means this is the ambiguous case of the law of sines. Whenever you have two possible results, it means you're dealing with the ambiguous case of the law of sines. So, let's try to solve this triangle. Notice that we have three pieces of information. You always have three pieces of information. And you have to decide, first of all, whether you can use the law of sines or use the law of cosines. What am I going to use here?
The law of cosine.
No? In other words, the law of sines requires that you have an angle and its opposite side. If you have those two pieces of information, then you're going to use the law of sines. Tell me what equation I can use to solve for that angle.
Sine of 67 degrees over 15.
Remember, you always take trig functions of angles, not sides.
I'm sorry, I misread it. Yeah, so sine of 15 degrees over 67 equals sine of theta.
I think that's delta.
Okay. Over x.
Okay. That doesn't help. Notice that I still have two variables. I have delta and x. So that's not the next thing I want to figure out. What side do I only have one variable?
93.
Okay, so I want the sine of v over 93. Now I have an equation that only has one variable in it. Let's solve for, first of all, let's solve for the sine of v, and then let's solve for v. So sine of v equals what?
Sine of v is 0.36.
Now figure out what v is.
21.1 degrees.
Now here's the leap that you have to make always. Whenever you're dealing with a triangle that might be ambiguous, and anytime this angle is less than 90 degrees, it might be ambiguous. Okay? So anytime you're dealing with a triangle that might be ambiguous, you have to get the second angle also, which is the supplementary angle to this one. What is that?
It's about 159 degrees.
Now the question is will that fit in our triangle? Does it? Hold on, the only known angle we have is 15 degrees. And what you're telling me is that that angle V can be either 21.1 degrees or 159 degrees. Does the 159 degree angle fit?
Yes.
It does. In other words, all it has to do in order to fit is be less than 180 when added to the 15 degree angle.
Right.
And what that triangle looks like is this. Remember, that's V. So that might be 159 degrees or 21.1 degrees. Either one works. And notice that in my second case, that's still 93. And that's still 15.
Right.
But everything else has changed. Now, so there's, first of all, let me erase that. That's not what we were able to solve for. We were able to solve for V. In other words, whenever you're using the law of sines, where you have an angle and its opposite side, then the next thing you have to solve for is whatever other piece of information you have, which in our case was 93. That was it. We didn't know S and we didn't know X. So we had to use this in our law of sines. When you do a law of sines, you only want one variable, and that's angle V. Okay?
Right.
And we solved for angle V, and notice why you always come up with two angles. Because the sine is positive in the first and the second quadrant. So if I tell you the sine of V equals 0.366, there's always two angles that satisfy that. In this case, V could be 21.1. In other words, if you put in your calculator sine of 21.1, you'll get 0.366. But also, if you put in your calculator the sine of 159, you'll get 0.366. So there really are two answers for V. The question is whether our triangle can stand two answers. And the answer is yes, it can, always. In other words, the only thing you have to do is add either of these answers to the only known angle we have, which is 15 degrees, and see whether or not 159 fits in. In other words, if this was 169, it wouldn't fit, right?
Right.
So if it was 169, I would not have an ambiguous triangle. I would cross it out, and I would live with the only other angle that I can have. So you're always trying to add this second angle into the only known angle that you know is in this triangle, which is 15 degrees, and seeing if it fits. And by that I mean, does that exceed 180 or is it less than 180? Well, in this case, it's less than 180. Therefore, it fits.
Right.
So you have two possible scenarios. And one is where that, I'm going to round everything off here. I hate the fact that they do this. I really do. It's inexcusable that they confuse this issue by adding all of these decimals that aren't necessary. Now hold on a second. Let me look at this. Yeah, that's not right. I'm not sure what's going on here, but let me think for a second. So V can be 21 degrees or it can be 159 degrees. Now the only way it can be 159 degrees I'm not sure what's happening here. Part of it, let me see what the question is again. There are two possible results. So it's telling you that you definitely have an ambiguous triangle case.
Okay.
Now, I suppose that doesn't necessarily mean there's two different angles for V. It might mean,
Oh, right. There would have to be.
well, look what they've done to this thing. Somebody's put some dots in there.
Yeah, that was me.
That was you? So, to me, that means that's the other triangle.
Right.
And there is your 159 degrees angle. Whereas that is your 21 degree angle. And notice that everything else is the same. The distance from the Earth to the Sun is 93.
Right.
The distance from Venus to the Sun is 67. And that's true in both of those triangles. Here, let me make sure you're clear. There's one triangle. And then let me draw the other triangle in red. And notice that both of those triangles have 93 and 67. This measurement right there is 67 of that side.
Right.
And they both have the same theta. Theta being 15 degrees. And that's how you solve when you, well, whether you know that you have the ambiguous case or not, the way you find out. In other words, you don't always know when you have the ambiguous case. And the biggest problem is determining when you do have the ambiguous case. And the solution is always figure out this second angle.
Right.
In other words, when you solve for V, it's not just 21.1. Remember, sine is positive in the first and second quadrant. So the sine of 21.1 is going to be exactly the same as the sine of 159. And so therefore, that would also satisfy the law of sines. And the question is does it fit in the triangle? Well, if this came out to be 11.1 and that was 169, then it would not fit in the triangle. 15 plus 169 is greater than 180. You cannot fit a 169 degree angle in there.
Right.
And if that were the case, then you would say, no, this is not the ambiguous case of the law of sines. But given the numbers they gave us, which were 21 and 159, it does fit. Fits like this. I was trying to draw it wrong the first time. that angle right there is 159 degrees. And the most important thing to realize is that nothing is violated in either of these triangles. You still have a 15-degree angle there. You still have Earth to the Sun is 93 million miles. And most importantly, you still have Venus to the Sun is still 67. In other words, that's 67 right there.
Right.
They could certainly come up with an easier thing to illustrate the ambiguous case of the law of sines. This is a tough one. I'm glad you drew those dots, because that showed me how to do it.
Yeah, this was, these pictures that I sent you, it's like different slides, and we had to do them in class. We were working in groups of 3 or 4, and with 4 minds in 30 minutes, we couldn't figure out a few of them. So.
Did you send me something else?
No, that's it for those ones. But I do need to send one more, even more confusing word problem.
Okay.
My teacher loves word problems. So.
Okay. Yeah, no, they have a way of making word problems be 8 times more confusing than they need to be. It really would have been just fine if they would have given that problem as angle this is this, side this is this, side this is this, solve the triangle. That's all you would have needed to say.
Right. Okay, I just sent it.
Oh, it came into spam again. How have you managed to get this into spam? So is this problem inside the rectangle?
Yes.
I'm reading it, excuse me.
No, you're good. Take your time.
So let's see if we can draw a picture. That's the biggest problem with these problems, is figuring out how to translate their paragraph into the picture.
Right.
So the hang glider is cruising this direction, and we've got the Parthenon down here, and it's at a constant altitude of, surely they didn't mean, well, maybe they did. That looks like 12 meters per second. Well, that's not an altitude.
No, it is not.
So that's the speed that it's moving. And this is some constant. How can the altitude be constant? Because as the thing is moving, the altitude changes. All right, let's see if we can figure out their error here. She looks down to the top of the Parthenon, and she makes an angle of 15 degrees. All right. 1 minute later, okay, now we're getting somewhere. 1 minute later, the angle is 52 degrees. if the Parthenon is 13.72 meters tall, so that distance is 13.72. And the building sits 150 meters above sea level. Oh man, so this is 150. I'm assuming they mean the bottom of the building. Approximately how many meters above sea level is the glider? So they want this distance. Well, that doesn't even make it. No, I guess that does make sense. We'll call that y, because it's a vertical distance. Alright, is this an accurate picture, you think?
Yeah, I think so.
Okay. So the first thing we can figure out is this distance right here. If the glider is moving at 12 meters per second, and this took place 1 minute later, what's that distance? If it's moving at 12 meters per second, how far does it go in 60 seconds?
Feet.
720 meters.
Meters, sorry.
That's all right. All right, so now, what do we know? We know this angle is 38. Something's wrong. That angle's not 38, excuse me. That angle is supplementary to 52, so that angle is 128, which makes this angle, let's see, that's 143, that's 37 degrees. So we have a triangle. Now, the question is, that's not really what we want to solve for. We don't necessarily need to solve that triangle, although we could because we have 3 angles and 1 side. In other words, as long as we have one side and its opposite angle, then we can use the law of sines to solve for that distance and that distance. Question is, they didn't ask for those 2 things. They asked for y. Well, I know this distance is 13.72 plus 150, so that's 163.72.
Oh, right. So you find it from, gotcha, you drop an altitude from the top one
they
to the
just
top
threw in those distances just to confuse you. Now,
Yeah,
let's see what they say at the bottom. E is equal to 408 meters. E being what? Certainly not eccentricity.
Oh, it's this problem, it's in a packet of a bunch of other problems. The whole idea is that you're pretending to be a quote CSI agent, and there's a bunch of different problems, and you solve them. And so if the answer were 502, you would circle that, or 512, you would circle H equals 112. And then in the end of it, there's a puzzle.
So you're saying these 3 things at the bottom don't have anything to do with solving this?
No, not at all.
Good. I don't want them to have anything to do with solving this. However, I'm not sure how I'm going to solve it. In other words, we can certainly solve this triangle. we have 3 angles and 1 side. So I can solve for that side and I can solve for the red side. Question is, how does that help?
Can't you drop a line from the top horizontal line down to the top of the Parthenon and make a second triangle? And then you find that green side and then add that to 163.72.
Yeah, you're right. I can, yes, that is the solution. Okay, so let's see. How do we find that green side?
You can find the bottom angle.
Because that's this angle, this triangle is 15 degrees here. It's 90 degrees here. And that makes that 75. And since that's 37, this has to be 38. No? Or am I going wrong here?
Yeah.
Okay, so there's, let me draw the green triangle in here. And that's what's 52, which makes that 38.
38, yeah.
Now, we know that that's 720 between there and there. And if we can solve for y, we will have solved the problem. Because we'll add y to 163.72 and we'll have the total height. Question is, can I solve that triangle, this green triangle? Yes, I can. Question is, how do I get this distance here from there to there? I know the plane or the glider is going at 12 meters per second, and I know that 1 minute after it was there,
Well, how do we know that the second jump is 1 minute?
we don't.
Wouldn't it be just over 1 minute?
We don't. We have no idea how long it took to go that distance there, x.
Okay.
Question is how long does it take for the hang glider to be right over the top of the Parthenon? Then we could solve for x. But, well, hold on. Maybe we have to solve this other triangle first. Yeah, there we go. Notice that if I solve this triangle there, I'll have this green line measurement.
Oh, right.
Once I have that green line measurement, then I can solve for x. Once I can solve for x, I can solve for y, and then I have our answer. So let's start with, I'll call this the red triangle.
Okay.
And what do we know about the red triangle? Use the law of sines. In other words, we know there's a 37-degree angle there, and we know that it's 720 there. So let's start. So how do you start that?
So sine of 37 degrees over 720 equals sine of 15 degrees over A. Yes.
Okay, so we're going to call that A. Now, once we solve, well, let's go ahead and solve for it just to make everything easier. A equals sine of 15 times 720 divided by the sine of 37.
310 is what it rounds to.
All right, so yeah, I can't believe they would not use whole numbers on a problem this complicated. It's not degrees. It's okay. So my green-red line is 310. Now let's look at that triangle.
Right. Okay.
And let me draw it separate so I can label everything properly. That's 52. That's a right angle. That's 38. And that's 310. Well, that's 90. So I can use the law of sines to solve for x and y. Well, let's just solve for y, because that gives us the answer immediately. Yeah, let me erase everything else here so I have some room to work in. So give me an equation I can write regarding this triangle that lets me solve for y.
310 times the sine of 52 degrees.
It's not times.
Divided.
It's not times. When you're using the law of sines, it's always ratios. So I could say the sine of 90 degrees divided by 310 equals what?
Oh, I'm sorry. I skipped a step. Equals.
That's okay. I don't mind you skipping a step, but it always confuses me when my students skip a step because I never know what they're doing. So try not to skip steps. But
okay. So sine of 52 degrees over y.
There you go. And then y is going to be equal to 310 times the sine of 52 divided by the sine of 90, which is 1. So y equals 310 times the sine of 52. Go ahead and figure that number out.
244.3. I don't know if you want to use the 0.3 or not.
Yeah, I'm not sure either. So we're going to add that y to that. In other words, the distance from the top of the Parthenon to the base plus the distance from the base to sea level is 163.72. William, are you still there?
Yes, I am.
Okay. No. Okay. I don't get these smartphones. Why is it so hard to take an incoming call? Whenever I have an incoming call, I can never figure out how to do it. The only option I seem to have is reject call with a message. Let me hit that and see what happens. Nothing happens. Crazy. All right. So that may be one of the toughest law of sine problems I've ever seen.
Yeah, that was no fun.
Well, and it didn't even involve the ambiguous case. The statement I've made to students for 8 years is that the only hard problem involving the law of sines involves the ambiguous case. But this is different. This was a hard problem and there was no ambiguity at all.
Right.
All right. Plus, it was confusing with all these things at the bottom.
Yeah, it took me a while to acclimate to this sort of assignment that they assign at Boston Valley. It's really weird.
No, I get it. It's middle schoolish. Or,
yeah, it's kind
or worse, elementary schoolish.
It seems more like busy work than it is actual, than it is constructive.
I don't quite get it. I get a lot of students that have this, and you end up with this big crossword puzzle, and each answer you get fills in a spot, and then you solve the crossword puzzle. Well, to me that seems like, wow. I don't get it at all.
Okay, so I'm sending one more from the same packet. And there's an answer filled in on this one, but I'm pretty sure I got it incorrect, so.
All right. So you don't think the 2880 is right?
I don't think so, because, well, the puzzle on the end, I'm not getting the correct answer, so.
All right. Well, let's draw a picture. Let's draw a picture.
Okay.
I can see the triangle they're talking about. It's this one. And that's 100 degrees. And that's 53 degrees. That makes that 27 degrees. Let's go ahead and fill in everything we know. And that's 1637. Now, usually all you need is 3 pieces of information to solve a triangle. And I've got 4. So, find the length of the bridge sounds like they're looking for that right there.
Oh, yeah.
Okay, so let's forget the problem they've given us and solve this picture. So what can you tell me? Start with the sine of an angle.
The sine of 27 degrees over 1637 equals the sine of 100 degrees over x. Or, sorry, not that x.
No, you're right.
Definitely.
It's definitely x. And that's the length of the bridge that they need. I mean, I didn't even read the problem, but I'm assuming that that's what they're asking for, is that bottom base of this triangle.
I think they're asking for the other side.
Okay, well, we can solve for all 3 sides here.
Right.
Oh, yeah, you're right. They are. They're not asking for x. Well, let's make x. Hold on. Let's make x this. Now give me a thing, an equation.
Sine of 27 degrees over 1637 equals sine of 53 degrees over x.
Yeah. And now that only has one variable. In other words, that's a number, that's a number, that's a number. X is going to be, if I cross multiply and divide by sine of 27, that's what that distance is, that they have said question mark, question mark, question mark.
Right.
All of these problems come down to a triangle, you can bet. So when you're trying to interpret them, try to draw the triangle, and they've given you as much help as they can here by putting 3 question marks. That's what they're asking for. And so when you solve for x, you will get their answer. I don't know if it's 2880. Did you do the math yet?
Yeah, it came out to
Okay.
So off by, so I rounded it. I did the math correctly.
Yeah,
But I'm
you did.
thinking that I might have gotten the final puzzle wrong because of the rounding.
Well,
because the answer that I got, I should have gotten 3,175, and I kept getting like 3,184 or something like that.
how is it so far different than 2880? I thought you came up with 2879 when you solved for the 3 question marks.
No, it's basically no different. I don't think it'll make a difference.
Yeah.
I'm just thinking maybe in the final puzzle I shouldn't have used the round.
Here's the secret to avoiding rounding errors. Never round off until the end.
Right.
As long as you do that, you will never have a round off error.
Yeah.
Just do not round off until the end. Or if you have to, in order to figure it out, round off to 6 decimal places or something. In other words, round off to a lot more decimal places than you need your answer in. Now, it doesn't say anywhere in here how to round it. Oh, yes it does. It says round to the nearest meter. So, in the middle of the question, make sure you round to the nearest hundredth of a meter. And then round off at the end, and you'll always be safe doing that.
Right. Okay.
Okay? Wow, how'd that happen? How can I do that? Huh. Wonder, I don't need my other program to do that. That's amazing. All right, is that the only problem on this page?
Yes, that one. And I'm sending over just one more.
Okay.
In just a second. Okay, I just sent it.
Haven't received it yet. I would expect it to come into my spam, just like the other two. Huh. It's kind of weird. I've never seen that happen where I get the first two, but I don't get the third one. Still not in spam. There it is. That's weird. It came into my regular. Maybe after I've opened both of those spams, Google recognizes this as non-spam. And so it puts it into my regular account instead of my spam filter. Wow, that's almost impressive that they've figured out how to make it that dynamic. All right, let me read this. Could they make it any more confusing?
I don't think so.
No, I don't think so either. Let's see. I hope you brought a water bottle. I should say I hope you brought a Valium. We started at 5:30, didn't we? We got 5 minutes to do this problem?
Yeah, I don't think it's enough.
Well, let me see if we can get it set up.
Okay. If not, then we have a session scheduled for Sunday evening too. So.
Okay. just trying to figure out how to draw the triangle. It's a triangle problem for sure. Well, let's see. We have some points here. Clearly that's a point, and then that's a point, and then that's a point, and that's a point, and then we have a point down here also, correct?
Yes.
Alright, so this distance looks to be 10, is that correct?
Yes.
And what is 20? Is 20 the measurement from the starting spot? Yeah, it must be.
Oh, yeah, it makes sense.
So that distance is 20. That distance is 30. And they don't give you the distance to Athens. Probably that's what they want you to solve for. I don't know. Alright. Wow, they don't label anything here. They really almost leave it up to your imagination, huh? In other words, we've got an angle U, we have an angle V, we have an angle X, and we have an angle A, and we have an angle W. I'm going to take a wild guess here and do that. And tangent, I'm going to call that W. I'm going to call that V. I'm going to call that U. And secant of A, that must be A right there. And that must be X. Does that make sense that I've labeled everything correctly?
Yeah, okay.
And here, let me make it a little...
3 triangles.
Right. And 20 was that distance there.
Yep. Okay.
Alright. Now, if we take the first triangle, this one right there, it says the sine of U equals 4/7. Wow. I guess that allows us to solve for this, doesn't it? If we can assume that this is angle U. Let me think about that. Let me think about that for a second. In other words, we have this triangle that I have the check mark in, and we know 2 sides, and we know the sine of U. So we know 2 sides and an angle, right? In other words, assuming that I've labeled U properly, that's a number. It's 4/7, the sine of that. That means I'm going to be able to figure out what U is. U is the inverse sine of 4/7. So once I solve, you see where I've drawn U?
Yeah.
Once I solve for U, I'm going to have side, angle, side, and by whatever means, I'm going to be able to solve that triangle that my check mark is in.
Okay.
And I'm imagining the way this problem is going to solve itself is by using that logic throughout each triangle and ending up with, I guess the distance they want is from the Marathon to Athens in a straight line? I'm not sure. Yeah, I like a real marathon from Marathon to Athens, but instead, you know, I'm not sure, but maybe they want something like that distance of that red line, which merely complicates the problem enormously. But notice what you can do with each of these pieces of information. In other words, if you've drawn a picture where you've identified u properly, then you can figure out what u is. It's the inverse sine of 4/7. And you can figure out what v is. V is the inverse sine of u over 2. So once you solve for u, you can figure v. And same thing for w. You can solve for w because you've solved for v already. And once you solve for w, you can solve for x. And once you solve for x, you can solve for a. So all of these involve taking the inverse trig function of what's on the right side of the equation. Now, I still am not sure my picture is even close to correct, but I think it might be. And even if it's wrong, that should help you finish this problem. In other words, you definitely have to go from, ooh, wow, I did not know you could do that. From that, solve for u. That will allow you to solve for v. That will allow you to solve for w. That will allow you to solve for x. That will allow you to solve for a. And it might be a that they're, yeah, the bottom thing says a equals what? So a is some angle. In fact, I'm not sure you have to draw a picture. The more I look at this, the more I think it's just a question of solve that for u, and then solve that for v, all the way down to a, and you end up with an answer. I don't think you need that picture at all, to be honest.
Okay.
I really don't. In other words, u is definitely the inverse sine of 4/7. And once you get that answer, you'll be able to solve for v, all the way down to a. And as soon when you solve for a, you'll have a number, put it in, that's your answer. There's no picture involved here.
In the little box in the middle left, it says each answer should be in radians. So
Okay.
I calculate the inverse sine and then just don't convert it to degrees.
Well, yeah, make sure that you're in other words, you can start in radians and finish in radians. That's the way to do it.
Okay.
In other words, with this right here, that first one, make sure u is in radians.
Okay.
Now with u in radians, you'll be able to solve for v, and v will be in radians. And then w will be in radians, and x will be in radians, and a will be in radians.
Okay.
William, I got to run. I actually have another session tonight. I don't know what's going on, but Friday, I never have anything on Friday, but today was different. So, yeah, I'm pretty sure that that will solve that problem. And it solves the bigger problem of how to draw a model of that. I have no idea how to draw those models, but you don't need to. Just need to solve for u, then v, then w, then x, then a, and put everything in radians, and that'll help. You might not be able to solve that if you were to work in degrees the whole way.
Yeah.
William, I'll talk to you Sunday.